Welcoming all the grade 12s. Welcome back to our winter classes. Welcome back to it. It's Maths Masterclass with Leo. I'm Leonard. Today we are doing a series and sequence. Series and sequences. Or we start with a number pattern. Right? So today I'm going to do an introduction of number pattern and some terminologies, things that you need to know and things that you need to avoid doing when answering number pattern questions, right? Okay, with number pattern, there are a few, I can say, sections that you need to check or subsections. So in this case, you need to know the linear pattern. You need to be able to answer linear question or arithmetic. This is the easiest. Arithmetic, linear or arithmetic. When they say arithmetic, they mean linear, right? So the basic formula for this, this looks exactly like a straight line. It's exactly like a straight line, and the formula for this is Tn is equals to A plus into n minus 1 close bracket d, where Tn represents the what? Tn represents, it is the term in a sequence. This represents a term in a sequence. In a sequence, right? For example, you have 7, maybe 9, maybe 11, and 13. So in this case, this represents a term, which means this is a Tn. This also represents a term, which means this is a Tn, right? This represents a term, which means this is a Tn. All of these things, they are Tn, right? Individually, so they represent Tn. All of them together, they represent a sequence, right? So that is why they are saying Tn is a term in a sequence. This is the actual number that you see on your sequence. As I was saying, this is an actual number that you see on a sequence, which is can be 7, can be 9, can be 11, can be 13. That represents Tn. And then A represents the first term. First term. In this case, our A is represented by 7. 7 is our first term, right? And then we have N, which represents the position of each term, right? Position of each term. That is our N, right? So in this case, if I look at this pattern, I can see that N for 9, the position for 9 is 2. The position for 11 is 3. The position for 12, for 13 is 4. That is what we call the position, right? In which position do you find 9? In this case, n is equals to 2. In which position do we find 11? In this case, n is equals to 3. In which case do we find 7? Meaning n is equals to 1 in position 1. Right? Okay, now we also need to know what is D. D represents our common difference. Common difference. Right? D represents our common difference. Right? And then now, in simple terms, this you can say A is equals to T1. Right? While D is equals to Tn minus T minus 1. Right? So in simple terms, in most cases, we say D is T2 minus T1. D is T3 minus T2. D is T4 minus T3. Right? That's how we identify the value of D, or what we call our common difference, right? That is how we will identify our common difference. And then when it comes to a linear pattern, there are also things that you need to know, like your sigma. You need to know what is sigma. sigma, which in most cases they write it like this, tk. This represents the sum. Sigma represents the sum of the terms in a sequence. This is the sum of the terms in a sequence. In most cases, this is equal to your Sn, right? Where your Sn represents the sum of the first nth terms. Sn is the sum of the first nth terms, right? For example, they can say, what is the sum of the first 9 terms? What is the sum of the first 10 terms? What is the sum of the first 19 terms? That is Sn. That represents Sn. Once they say, what is the sum of the first 5 terms? You calculate the value of Sn. And Sn in this case, the formula for Sn, we have 2 formulas, which is, the first one is Sn is equals to n over 2 into a plus l, right? Where a is your first term and l is your last term. And how do you see that l is your last term? In most cases, they'll do this. They'll say maybe 7, 9, 11, 13, and then da-da-da. And then maybe they say 26, for example. Maybe they say 26. They're saying 26 is your last term. That's how they'll represent it. Ne? That's how they'll represent your last term. Or they say 7 plus 9 plus 11 plus 13, then plus 26. Meaning this is your last term. This goes there, right? And then the second formula that you have, it says Sn is equals to n over 2 into 2a plus into n minus 1 close bracket d, right? That is your second formula for Sn. So this one is very basic. If you have the value of a, you have the value of n, and you can calculate the difference. It's easy to use this one. This one, you just need to be given the last term, always, for this one. And for this one, you just need they need to tell you, calculate the sum of the first 10 terms, that is the value of n. Then you can calculate the value of a if you have the sequence. You can calculate the value of d if you have the sequence. That's it, right? And in most cases, this looks exactly like a linear function. Looks exactly like a linear function, right? Because the the solution will be something like this. Tn is equals to dn plus c, right? Which is similar to y is equals to mx plus c, right? So whenever they did not tell you this is an arithmetic sequence, look for this. If you can find this, then you can already conclude that this is an arithmetic or a linear sequence. But we'll do questions on that so that you understand better, right? So the first question that we're going to do on linear is just calculating the next 2 terms, calculating the Tn, and calculating the position of a certain term, right? Okay. The first question that we have, the sequence is 1, 3, 5, 7, 9. Right? So, the first question, they want you to calculate or determine the next 2 terms. They want you to determine the next 2 terms. Right? So, for you to calculate the next 2 terms in this case, you just say, calculate the difference first. What is the difference? So, here, from here to here, you can see that this is 2, this is 2, this is 2, and that is 2. Right? It means it will continue saying 2, then 2 plus 9, 11, then again 2, 2 plus 11, 13. This and this are your next 2 terms. So your next 2 terms is 11 and 13. 11 and 13. Right? Some you will say, in this case, I don't want to use this. I can use the formula and say, from that I can now say Tn, or in this case I count 1, 2, 3, 4, 5. This is term number 5. I want to know what is term number 6. I substitute 6 here. T6 is equals to my difference, what is my difference? Okay, I know my formula is, okay, let me do that instead of jumping. Tn is equals to a plus into n minus 1 close bracket d. This is my formula. I want to know what is T6. Term number 6 is T6 is equals to a is represented by 1 plus into 6 minus 1. The difference is 2. And then this will give me 1 plus into 5, then 2, which is 10 plus 1, which is 11. Right? And then if I want to calculate T7, I'll say T7 is equals to a is 1 plus into n is 7 minus 1 close bracket 2. This gives me 1 plus into 6 multiplied by 2, which is 1 plus 12, which is 13. Right? That's how you can now calculate the next two terms. Either you can use this format or you can use this format. Whichever format that suits you and whichever format that you like and prefer, you can use it. Let's go to the next page. Okay. Now, the second question is to determine the formula. Tn, we know that Tn is equals to a plus into n minus 1 close bracket d. And we know d is calculated by saying T2 minus T1, right? When I remember T2 was 3 minus 1. This is equals to 2. I can also check to confirm if ever this is an arithmetic to say T3 minus T2. This I know is 5 minus 3. This is equals to 2. Therefore, I have the common difference. It means I can now continue with my work. Then Tn is equals to value of a is represented by 1 plus into n minus 1 close bracket 2. Then this will be 1 plus 2n minus 2. Why? Because I multiplied this inside. And then this will be 2n minus 1. That is my general formula. Right? That is my general formula or my nth term. If they say calculate the nth term, they mean calculate, this is the formula. The formula, right? Or sometimes they'll just say the general term. This is ways in which they can try and trick you. General term. General term or the nth term, they are simply talking about the formula, right? So the next thing is to calculate what is the 20th term. What is the 20th term? What is the 20th term? So in this case, they want to know if they say 20th like this, 21st, 23rd, these things, they are simply telling you calculate the value of what? Calculate the value of Tn. You are given the value of n. This represents the value of n. This is the value of n. So they need you to calculate Tn. Right? So don't confuse these two and say they want me to calculate n. No. They want you to calculate Tn. They gave you n. So in this case, Tn is equals to 2n minus 1. That is my formula. They want me to calculate this. I can say now T20 is equals to 2 into 20 minus 1, which is 39. That is my solution. Right? That is my solution for them saying I must calculate the 20th term. The next question is to calculate which term is 57. Now they want the position. They want the value of n. Right? So in this case, you'll say Tn is equals to 2n minus 1. And then 57 is equals to 2n minus 1. And then 57 plus 1 is equals to 2n. This is 58 is equals to 2n divided by 2 divided by 2. There and that they cancel. N is equals to 58 divided by 2. It is, let's see, we'll get a calculator. Okay, now 58 divided by 2 is 29, right? So 29 is your solution for the value of n. That is how you can calculate the value of n for an arithmetic sequence, right? Now, let's go to a geometric sequence, things that we need to know when it comes to a geometric. A geometric sequence, the formula for a geometric sequence is Tn is equals to an squared plus bn plus c, right? That is the general formula, or the nth term, right? This is the nth term or the general term or the formula, right? Okay, now that is our formula. Then now you need to be able to calculate the value of a, the value of b, and the value of c. The way to calculate the value of a is, say 2a is equals to d2, which d2, it is the second common difference. Right? This is the second common difference, d2. Now you need to be able to calculate d2, and d2, the way to calculate it is to say this is equals to t3 minus t2 minus into t2 minus t1, right? And then 2a is equals to d2, then 3a plus b is equals to d1, right? And then a plus b plus c, this is equals to what? Is equals to your t1, which is your first difference, your first term, not your first difference, but your first term, right? Now d2 is equals to this, right? And again, we can say again d2 is equals to t4 minus t3 in bracket minus into t3 minus t2. Then we can see that d2 and d2 are equal. It means t3 minus t2 in bracket minus into t2 minus t1. This can be equals to t4 minus t3 minus into t3 minus t2. That is it, right? This quadratic, it looks like a parabola. The formula for it looks like a parabola formula, or a quadratic, as it says. This is a quadratic pattern, right? And then this formula Tn is equals to an squared plus bn plus c looks exactly like y is equals to ax squared plus bx plus c. It's the same thing, right? It looks exactly. And what you need to know always is, let me do that and write it in red. When you start calculating the differences on your pattern, d1, or the first difference, or the first difference will be a linear sequence. You will see when you start doing, will always be your linear sequence. When you're dealing with quadratic, d1 will always be a linear sequence, right? So now let's get to do problems. Simple problems. We have 1, 3, 7, 13, right? So this is our sequence. The first thing we need to calculate, what do you call your next two terms? Calculate the next two terms. Okay, let me write it in red. Next two terms. terms for this sequence. So the easiest way to do that, I always do this. And say I have my 1, give it space, 3, give it space, 7, give it space, and 13. Then when I say this minus that, I'm going to get 2. T2 minus T1, I'm getting 2. T3 minus T2, I'm getting 4. T4 minus T3, I'm getting 6. Can you see? This is a linear pattern. 2, 4, 6, 8, 10, 12, 14. That is linear, right? So after that, I can now calculate. This is my D1. I can now calculate my D2. D2, this minus that is 2. This minus that is 4, right? No, not 4, but 2. Why am I saying 4? That's 2, right? And then now, I need to check the next 2 terms. If you look at this is a pattern. Let me show you something. This is a pattern, and it's the easiest way to do this pattern. Look, when I say 3 plus, okay, let me start here and say 7 plus 6 is 13, right? 3 plus this is 7, right? So here I'm going to have 8. Now when I say 13 plus 8, I need to get the next term. The next term will be 13 plus 8 should be 21. 13 plus 8, 21. I told you this is 2, 4, 6, 8. It will be 10 here. So 21 plus 10 is 31. So these are my next 2 terms. Those are my next 2 terms, right? I hope you understand. That is how I'm going to calculate my next 2 terms. Easy as that. Now the next question, they want you to identify the nth term. Nth term. By now you know what is an nth term, right? So in this case, remember that this represents my second common difference. Remember that this D2, that is D2, that is D1, the whole pattern. And then now in this case, remember, for me to calculate the value of A, we said 2A is equal to D2, second common difference. So in this case, my second common difference is 2. So 2A is equal to 2. Then A is equal to 1. When I divide this by 2, both sides, I'm going to get 1. Right? And then we said 3A plus B. This is equal to D1. Right? So in this case, always take the first term of D1. Take the first term. So in this case, it will be 3. A is represented by 1 plus B. This is equal to 2. This is B is equal to 2 minus 3. Therefore, B is equal to negative 1. And then lastly, we need to calculate C, which is A plus B plus C. This is equal to T1, your first term. So in this case, A is represented as 1 plus into minus 1 plus C. This is equal to 1. Therefore, C is equal to 1. Then my formula will be Tn is equal to, the value of A is represented by 1, meaning I'll have n squared. The value of B is represented by minus 1, it means I have minus n, plus the value of C is 1. That is my equation. That represents my equation. Okay, the next question, we need to check the 20th term. What is the 20th term? 20th term. The 20th term in this case will be substituting 20 where there's n. This is t is equal to 20. T20 is equal to 20 squared minus 20 plus 1. Then 20 squared minus 20 plus 1. This gives me 381. 381. Last question for this is, let me see. So in this case, we have we're looking for our 57 term. Which term is 57? Which term is 57? Which term is 57? So in this case, we will say Tn is equals to n squared minus n plus 1. Then Tn is represented by 57, so I'll say 57 is equals to n squared minus n plus 1. And then rearrange, I'm going to have n squared minus n plus 1 minus 57. This is equals to 0. Then n squared minus n plus minus 56. This is equals to 0. Then I need to factorize. I need to factorize n equals to 0. And then 1 will be minus, 1 will be plus. So let's see. Which terms do I have here? 8 and 7. So in this case, n minus 8 is equals to 0. N is equals to 8. And n is equals to negative 7. So n cannot be negative 7. Therefore, n is equals to 8. This part is very important. The last part that I just did is very important. Let me give you things that you need to know about the value of n. Right? Things that you need to know. N. Value of n cannot be negative. N cannot be a fraction. Or decimals. N cannot be 0. Right? So n is always positive whole numbers, positive integers only. That is n. So in this case, once you do this, there's a mark for this. N cannot be negative. N is therefore the value of 8, which is positive 8. That you get a mark for that. And now, last but not least, it is our geometric pattern. A geometric pattern. You did this in grade 9 when you did that spider. Geometric pattern. So with a geometric pattern, this is what you need to know. Tn is equals to a r to the power n minus 1. This is the formula. A is equals to T1, which is what we know. R is equals to Tn divided by Tn minus 1, which is similar to saying R is equals to T2 divided by T1, or R is equals to T3 divided by T2, right? Or R is equals to T4 divided by T3. That is similar. This is similar to all these three, right? And then now we need to know Sn. For this, Sn is A into n into r to the power n minus 1, r to the power r to the power n minus 1 divided by r minus 1. Or another one, it says Sn is equals to A into r to the power n into 1 minus r to the power n, right? Divide by 1 minus r. So these two formulas, they mean the same thing. As long as you substitute everything correctly, so you will be able to get the same solution. If you substitute everything in the correct manner, your solutions must be equal, must be the same, right? Then you have S to the s infinity, this is equals to a over 1 minus r. You use this formula when your value of r is in between minus 1 and 1, meaning the value of r is convergent or it converges, right? So this is when we use this minus 1 and 1. Don't forget that. And then we still have, again, tk is coming back. Sum of tk is equals to your Sn. Then this looks exactly like an exponential function. Tn is equals to a to the power ar to the power n minus 1. This is similar to y is equals to a b to the power x minus p. Very much similar. Very much similar. Then with introduction to geometric, we're almost done. Let's do a question. Say now you have 2 is to 6 is to 18 is to 54. They want you to calculate the next 2 terms. So in this case, this is a geometric pattern. You need to know what is the value of r. R is equals to T2 over T1. Or r is equals to T3 over T2. Always make sure that this is really indeed a geometric pattern. So in this case, I have 6 divided by 2. This is equals to 3. Then I'll have 18 divided by 2. This is also 3. Then therefore you can see that the ratio is common in this case. Common ratio. Common ratio means that is a geometric pattern. That is a geometric pattern. Right? So in this case, after calculating the common ratio, we need to know this is T number 1, 2, 3, 4. So R is equals to T4 over T3. What am I calculating? I'm calculating the next 2 terms. R is equals to T4 over T3. We know what is the value of R. R is 3. This is equals to T4. Do we have it? Oh, 1, 2, 3, 4. Oh, we have it. So we need T5. T5 over T4. Right? Then T5 over 54. Then cross multiply. What is 54 times 3? T5 is equals to now 162. That's how you can calculate your T5. Then if you want to calculate your T6, you'll say R is equals to T6 divided by T5, where 3 is equals to T6 over 162 divided by 1, cross multiply. T6 is equals to 162 multiplied by 3, 486. That is how you can calculate the next 2 terms. In this case, you have 162 and 486. Right? Now let's check the next question. The general formula, or the nth term. The nth term for a geometric sequence is very easy. Very much easy. As long as you know what is the value of r, then you are done. You have the sequence, you know what is the value of r, then you are done. So in this case, there's no need to calculate the value of a, no need to calculate any other thing, but just your ratio. So in this, we know Tn is equals to a r to the power n minus 1. And then we know what is this. This is your first term, 2 into r, 3 to the power n minus 1. So what you mustn't do, do not multiply this 2 and 3 and say this is equal to 6. You do that, your solution is wrong. These are not like terms. They can't multiply. They'll just stay like that. They'll always be like that. They can't multiply. Right? Don't forget that. You can't multiply the 2. No way. Okay. Then this is your formula. Now let's get the 20th term for this. It's going to be large. 20th term, it's going to be very large. So in this case, you'll say Tn is equals to 2 into 3 to the power n minus 1, where now T20 is equals to 2 into 3 to the power 20 minus 1. Let's see. 2 into 3 to the power 20 minus 1. I'm getting 23, 24, 5, 2, 2, 9, 3, 4. If you are good in numbers, you can just call out that number. What is that number? Okay, now the next thing is we need to calculate, right? When are we going to get this term? Which term is this? Which term is 13,122? Yes, 13,122. Now, we need to know. So, it means here we have the value of Tn. We have Tn is equal to 13,122. We need to know what is the value of n. So, Tn is equal to 2 into 3n minus 1. Then this is 13,122 is equal to 2 into 3 to the power n minus 1, right? And then remove this 2, remove this 2. I'm going to have 6561 is equal to 3 to the power n minus 1, right? And then can now say 6561 equals to shift facts. I'm getting 3 to the power 8 is equal to 3 to the power n minus 1. Then bases are the same. I leave them out, deal with the exponents. 8 is equal to n minus 1. Then 8 plus 1 is equal to n. Therefore, n is equal to 9. That is the solution. And that is it from us with a basic introduction of number pattern. In the next video, we will be discussing some of the series, how to use those formulas, your SN, your TK, and your summations, right? Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Danko means thank you. Danko.